Hello, in this video we are going to discuss a naive classifier using Python in a Colab book notebook. In our previous video, we had discussed naive classifier as an theoretical way. So, as we know, naive classifier is not only one algorithm; it is a collection of algorithm that works with the Bayes theorem. Right. Before wasting a lot of time, let's come to the coding side. So I have uploaded a one playtennis.csv that in our previous video, while we are discussing the naive in a theoretical way, I did an example for the play tennis. Now I'm just using the same playtennis.csv as for the programmatical way for a real world algorithm and to you put this value to feed this CSV in our algorithm, and then we are taking the some kind of performance and accuracy of our model. So what I did over here, I have uploaded the play tennis.csv, clicking on the play upload to session storage, and on the top I am using a import pandas and scale learn model selection. I already discussed the pandas and sklearn model in my previous video. So the pandas is a open source library. It works on the multi-dimensional data source, and sklearn model selection is a also again a open source library. So I'm using a import train test split. As we know, our model uh, totally works on testing and training. If we train our model with a huge data source, then our model will work perfectly on a testing environment, right? So here I have imported this thing to library, running this code, and also in the line, this the new line of code, I have add a variable name call names and make it a array for outlook, temperature, humidity, windy, and play. And also I have made a name, the data frame name of play tennis, and I have uh, read the pd dot read csv and give the path of my data source. So in my case, the data source is my local storage, so that's why I did not use a full path. And the name of column, I have made a pass the whole value of my column. If suppose if my data set names are different, like column wise, so like there is a o t h w and play, but I want some appropriate name, so that's why I have passed the column name. And then the header is none, and at the end play tennis start head, I'm using only printing for the printing purpose, I'm just printing the 20 record. So when I click on this, we can see that we have all this value, but here we are facing one issue, the outlook, temperature, humidity, windy. This is same header repeating twice on the top and on the bottom. So let's remove this line, the second line. So what I'm using, play tennis index 1 to onward, dot mean ignore the first index and go get the all index, right? So this is a the Python syntax to read the data from the collection. And when I click on this again, I'm printing that. Now we can see that the second row, the first row with the outlook, humidity, and all this stuff is removed, and we have the actual value here, right? Now, as we know, our whole data source, our whole data set having the string value, there is no integer value, the numerical value, right? So for that, and also these all value are the not ordinal value. So there are two different concept, ordinal and numerical value. So might be we will discuss that in later, like ordinal value, what does this mean, and categorical value, what does this mean. But consider this a simple data set, right? And what I'm doing, I'm making it a encoding my data value in a numerical value. So I'm using a sklearn pre-processing import label encoder. And for the data pre-processing, I have already implemented. I already uh, design or implemented data pre-processing in my previous video, where we are using a data cleaning, data processing, data wrangling, the techniques of how we can cover the all kind of pre-processing, like mean mode and and some other value, some grammatical issues, or sometime standard issue, non-standard issue, all this stuff I have discussed this all these things in my previous video. And I'm using a le as a reference variable for label encoder, and then I'm passing the outlook and le dot fit transform. We can use a le and then fit two in a two different way, le dot fit and le dot fit transfer. These, like, we can use like this as well, le dot fit. It will take a again parameter, or there is another way, le dot transform. So like it is also getting the two, but that will give us that there's some more line of code, or we can use both in a just one method, le dot fit transform. Then I'm passing the my data source column name, of the feature name, the column name, all this stuff. And I have passed all the my column, because my data set have these column: play, wind, humidity, temperature, and outlook. So also at the end I just print the my data set again. When I click on this, we can see that we have the all the string value is converted to the numerical value. But this sound is not appropriate for like how the system automatically convert 2220 111110 like this. So this is a label encoding, meaning that this is a data imputation in simple wording. So what does this meaning? The label encoding make the classes for the values, like in the case of just consider in this way. Suppose we have a size of share, like there is a size for large, small, and medium. And suppose we have make a medium as like small as a 0, medium as 2, and extra large or large is 2. ठीक? All right, so this is the same thing. So it has make the sunny as 2, and 0 as for might be for the overcast. I don't know what it is. Yeah, for 0 for the 2 for overcast. So it has made all the classes in itself in the model, right? So whenever we want to decode again, so it will automatically convert these classes into this particular data set, right? So at the end, what I'm doing, I'm making a feature column underscore names, and I have made a name for my column, like outlook, temperature, humidity. So uh, and also I'm reading the play tennis. This is my data frame, and passing the my name of feature column, and I am using a x for the feature column, y for the play tennis. As we know, as we know, the naive based classifier works on the Bayes theorem, right? So we are using for x and y. In that case, x meaning that your maximum number of class, I mean feature column meaning that your extra column, outlook, temperature, humidity, and all that. And the play is your target, so what actually we are going to achieve, right? So x and y, and the train test split, we have used this in the model selection on the top of the library, on the top of our code sklearn library model section. This one, why we are using that? Because as we know, we have a support data source. Like in our case, we have only one csv, and we want this csv for both cases, for the testing and for the training, right? So that's why we have give the feature and y, and giving the test side, meaning that I need 30% of my data set as a testing data set, and 70% as a training data set. And then the random state, meaning that shuffle the data, pick up the 100 time, and then get make it a 30%, make it a selection for testing. So this is for random state. So and this method return x train, y x test, y train, y test. When I do run this, and that's done, we all the testing and training variable are populated with the with all the value. And in over here what I have did, I have import sklearn naive As we know, naive is a not only one algorithm, it is a collection of algorithms. So I'm using a Gaussian NB. So this is a sound like a, some call it a Gaussian, some call Gaussian, whatever you want to pronounce it, it doesn't matter, right? And we have make it a model. We can name it anything, instance of your model. The model is a Gaussian NB, and model dot fit, we are fitting, feeding the model with the x train and y train, meaning the feature value and the target value of our model. We are feeding the feature value and the target value to our model. When I click on this, our model is fed with the actual value, the feature value and the target value. And over here we are getting the model dot predict, what model will predict for us for a feature value and target value. When I click on this, the model is returning 0 1 1 1 0 1. So for the new person, if I want to give the example of someone like my model is returning a 0 1 1 0 1, so he will laugh on us like, what does this mean? So for that, if we give if we give them sound like, my model is performing a accurate 100% accurate, my model is accuracy is 100% or 80% 90%, then this sound like a understandable to a new person, right? For that I'm using a matrix, sklearn import matrix. So this matrix give us a accuracy of our model. And over here just make it a print Gaussian and b model accuracy, and the matrix dot accuracy x test and y prediction, and multiply by 100, meaning that if I do not multiply with the 100, let me remove this. When I click on this, you can see that 0.6. So that is if I multiply by 100, so it will give us a 60%, right? So now we can see that we have feed our model, we get the prediction of our model, and we check the accuracy of our model, and that is a 60%. That is not good, right? uh, as I already had discussed in my previous video, if our model is accurate, like if model is returning a 70%, 80%, 90%, near to 100%, almost no model will always give you 100% accuracy, as per my knowledge and as per my information, as I know. But if model is giving you 80%, 70%, 85%, 90%, that model is considered as a very intelligent model, and well trusted model, right? So this model is rating 60%, so this is kind of like a not too good, not too bad, right? So how we can improve our model? There is a different way to improve our model. If I come on this model Gaussian NB, this is a library, the official website. There is a parameter, attribute, and all the stuff related to this one. So when we read all this stuff and we will tune our model with a different parameter, then might we will get a better accuracy. Consider in a way, suppose you are working with a huge data set, huge data source in a programming language like a Java, C++, or C Sharp, whatever, and your code performance is not good. So what you will do, you will optimize your code. When you are using that, this is unnecessary thing I have to remove, I have to use this way. So the model works in the same way. We tune our model with different way. Test and trial version. We we put some data, and then we tune our model, like we change some parameter, then we check the accuracy. If that is good, that is good. If not good, then we again change our model, tuning the model, changing the parameter, changing and the hyper parameter, all this stuff. Then with all that we will get a some kind of better accuracy. So this is about the naive classifier. So thank you for watching, and I will come with the next video for next topic with the next video.